Hey.
Sorry for the setup time. That was a little annoying.
No, not at all. I feel like I've taken easily twice that amount of time wrestling with Zoom and whatever. And we're in new territory. We're doing Discord now rather than Zoom.
Yeah, it's nice though.
Is Discord like a huge company? Do you know anything about them?
I truly don't. Yeah, I'm not really sure what their deal is, but they sure seem to have a lot of resources, and they're like running a Slack and a Zoom competitor at the same time.
Yeah. And everybody uses them, right?
And a Twitch
Like,
competitor?
huge.
Yeah.
Yeah. It's crazy.
It's pretty weird. I'm not sure. Yeah. I'm not sure what their shtick is.
My impression is their tech is probably pretty good. They're running Erlang.
Oh, nice.
Generally pretty good for real-time internet stuff. I think it's actually Elixir they use. So they're probably a bunch of ex-Ruby people, right?
Great choice. Yeah. Yeah, we got some early previews of Elixir at Heroku because we were an Erlang shop and a Ruby shop, and they were really excited to show that off to us. It was neat. I'm not sure it ever got picked up while I was there though.
What did Heroku use Erlang for?
The entire routing stack, which was actually like kind of a good use of Erlang, because it wasn't originally like a language for telephone switching.
That's right.
Yeah. So someone just saw it and they're like, oh, well, like we basically have to do telephone switching between the outside world and our collection of VPSs. And so they just wrote an Erlang router. And it powered like tens, hundreds of thousands of requests a second. It was a good router.
Nice.
Yeah.
I remember talking to Keith about that. Keith, our former coworker. And he was a little bit less enthused about Erlang when I asked him about it. I think he mentioned that like Heroku used it in some capacity, but I didn't actually remember exactly what it was used for.
Yeah, it was that tiny slice of the stack, but it was the very important slice. But at the same time, I think it was, challenging to modify. The community wasn't as big or deep as the Ruby community. Yeah. Finding other engineers to work on it was hard. So I think it definitely had a price.
Yep.
And also, it was potentially the cause of that entire like Rap Genius Heroku incident where they called us out for our router being busted. So, it's what they started the company with, and I think it lasted maybe too long without getting rewritten. I was still impressed, though.
Yeah, it feels like the sort of consideration of like whether or not people in the industry know how to work with the language. That feels more important to me than it ever has in the past. I used to be pretty language agnostic, and it's like, yeah, whatever, it's just a language. But now it's like, if you know that it's going to take someone like probably realistically, 3 to 6 months to really get comfortable in the language, and you multiply that over like an entire growing team, it becomes like a very serious consideration, right? I guess that's that's sort of like the motivating. It's sort of the reason for existence for Node.js, right? It's like, I don't want to teach people a different language. Let's just use JavaScript for everything.
Well, I think it's definitely the prevalence and victory of React seems to be another good case for that. Yeah.
Yeah, totally.
And why we have React Native, which is a very weird language.
Oh yeah, I keep forgetting that you do React Native. And
I like React Native even, but like it's bizarre. Yeah, it's a very strange JavaScript bridge to native code that like I'm surprised it works. I'm surprised.
Do you find
that
you can tell when apps are React Native apps?
I cannot.
Okay.
If they're done well.
I don't know if that's a thing. I was just asking if you had that kind of thing happen to you.
I can tell sometimes if it's like badly written, but also I've seen very badly written native apps, so like it's kind of the same thing.
Right.
Yeah, it's like when the transitions and all the little edge cases aren't hooked up together. It's really obvious, and I think it's just easier to make a React Native app that doesn't do that stuff.
Yeah.
But now the performance feels really similar to me.
Interesting. I wonder, it's funny because there are some interfaces that feel web pagey to me. I remember when I saw the screenshots and the UI demo for PS5, right?
Oh yeah.
When I saw that, everything looked very web pagey to me.
Wait, did you know that the PS5 is React Native?
No,
Oh, it actually is. Yeah, yeah.
What? Are you serious?
I talked to I'm friends with the developer there.
Okay.
It was just like, yeah, the new console UI React Native. We just JavaScripted the whole thing, and I was like, did you know?
Oh, that's so interesting, because I actually saw a slide deck from a Sony internal tech team about how they were going all in on Flutter as their like embedded UI thing, but not PS5 per se. It was just like Sony hardware. So like your smart TV interface or something like that, right? They were really into Flutter for whatever reason.
I mean, I could be wrong. I got this information in like February of this year when I was still seeing people in the world. So
yeah,
could be silly, but also he tried to poach me to write some React Native for him. So like, sounded real.
Yeah, I mean, I've got a friend who works out of the Foster City office for Sony, and so yeah, they might know.
I'm curious. Yeah, I wonder if he was referring to the new PS app on the phone too. Which have you installed it?
No, I never had a PS app on my phone. Is it good? Is it useful?
It's bizarre.
Okay.
It's a truly strange. It's a strange app.
Is it kind of born out of the like a corporate meeting room where the executives are like, we need a mobile presence?
I feel like that's what the old one was. This one feels like someone went back to like 1995 and they're like, what would be a really cool looking thing? Which is how I feel about the entire PS5 too.
So does it look like Kai's Power Tools or like what?
Yeah, that's a great,
Okay.
It kind of looks like Kai's Power Tools. There's a lot of slidey panels.
Yeah.
There's a lot of like weird curved bits.
Skeuomorphism?
If it's skeuomorphic, I'm not sure what it's skeuomorphing.
Right, but it is like modeling
materials,
like shapes, right? Like not just shapes, but it's like modeling like physical things moving around in a space, right?
Sort of, yeah, but like in a very Kai's Power Tools way. I haven't thought about that in years, but yeah.
Right.
But I would believe that this is React Native for sure as well, and also feels native. But like, man, they made some weird choices.
Yeah. Because I wonder if your mentality when you design a UI. The reason why I ask is that like React presumably would dictate the way that you think about the interface itself. I mean, it shouldn't, but it does have this kind of like static web page paradigm, right? And in particular, like transitions are weird in React, right? Like animating things from point A to point B. And I assume the other paradigm that you would use to design an AI is to make it like our video game, right? Which, as we're discovering, it has a little bit of overlap between like a React website, but the interaction paradigm is very, very different, right? It's like frame over frame, draw this thing there, right?
Yeah, well, and actually on the React Native side, they've added some very nice primitives for that. They have React Native animatable, and it hooks into the Android and iOS like animation libraries. And that's awesome. And you generally can't make it also without using like React Router, which does like screen transitions and navigation stacks and like card overlays using the native views. So it busts out of the traditional like website paradigm a little bit. Yeah. Because otherwise I agree it'd be really weird.
React Router. Oh man. I haven't done a React like a legitimate React site in a long time, but I remember just fighting with the router constantly. It's a very weird piece of software.
Yeah. Is it React Router or is it React Navigation? There's one of them does one thing and one of them does the other, and only one of them works on native, and I forget which.
Okay.
And I use it every day still.
Whatever the one that we worked on together. The one that it would push like URL paths into the browser history, right? And I always found it strange that it used JSX, it used like the HTML structure to define the actual navigation hierarchy.
Yeah. Still exactly like that.
Okay, yeah. So somehow JSX not only became your layout engine, it became your configuration engine as well.
Right, it was like declarative routes.
Yeah.
As a strange paradigm.
Yeah. Well, so this week we've arrived at a point with the game where we're kind of squeezing the rock a little bit more, like for optimization things. But I think we're getting to a point where we want to maybe reflect on our multiplayer implementation a bit. So what's coming out down the line next week? I got a cough. Hang on a second. I can feel it coming. Excuse me. What's coming down the line next week is I invited my buddy Steven, who's actually a legitimate professional game developer.
What are we? Are we illegitimate, unprofessional game developers?
Yes, I think that's exactly the right description.
Actually,
yeah. That's part of our charm, Dom. I'm not saying it as a bad thing, but that's what we are. But we're getting a little bit of adult supervision. We're going to bring on my friend Steven, who I used to work with in the game industry before I forgot everything about how to make games. And we'll hopefully have a chance to talk to him about, I guess, whatever he's interested in talking about. But what we're interested in a little bit is like, are we totally off the rails with our multiplayer implementation? Or are there little tweaks that we can do that we just haven't thought of yet? Right.
I'm looking forward to that a lot because I really enjoyed just briefly getting introduced to him. So it's gonna be fun.
Yeah. He's a great guy. So ahead of Steven coming in, maybe we don't need to talk too much more about multiplayer this week, and that gives us a couple days to kind of just like go off the rails and do whatever we want. Right.
Sounds great.
We're talking a little bit of graphics off stream. Maybe we can start with, well, actually, let me talk a little bit about like the changes that were made over the weekend, and then we can talk about graphics. Does that sound okay?
Sounds good. Yeah, those were nice. Here, I'm putting the code on the screen. There we go.
Yeah. Okay, maybe the easiest thing to I don't care about Manchester United. I guess that's the default thing if you type Manchester.
If you type Manchester, I think you get Manchester United.
You're not going to get Jeff and Dom on GitHub?
Not yet.
Because you should.
Not yet.
Someday we'll be bigger than the city.
Give it time. We will get there.
Yeah. So nothing too dramatic. We talked a little bit about last time moving the transform object, or the transform component, into the component table data structure. And the component table, once again, was basically a mapping between entity IDs and component objects, all of the same type. That also kind of has this database style rollback and commit mechanism, right? And what's the current state of the world is that we actually we actually have everything in component tables now, right? You'll notice that there's a different data structure here called an entity set. I went ahead and created this thing because it's basically a component table where the type is null. All we care about with entity set is the presence of an entity ID. We don't actually store any actual meaningful data.
Oh, that's great, because just having all those booleans around, I felt was kind of a weird hack on, like, they're not actually value objects. That's great. Yeah.
So I think it's actually a little bit similar to the kind of dichotomy we had between the sorted map and sorted set. We have here component table and entity set. Unfortunately, they're not like 100% the same word, but they're basically analogous concepts. So if you go into here, it actually kind of looks really, really similar. It also has this kind of database style rollback and commit thing, which is what we do to optimize our multiplayer implementation.
Nice.
But otherwise, we're fully in the world of just like, there's no longer a set of entities anywhere. Like, there's no entity object that the entity manager keeps track of. Entities are just IDs that are basically primary keys into a bunch of these things.
Nice.
And then as a slight optimization, just to reduce some boilerplate, I actually made a common interface for these two classes. So you'll see that if you look at the very top of the declaration, this implements something called an entity state container. The component table does as well. I don't know if this is the right word. Maybe this should have something to do with like the fact that you can roll back or commit. But basically, it's just these 4 functions.
Okay, not even a getter, because only component tables have a getter.
That's right. Yeah, so the getter side of it, you're exactly right that only component tables have a get, because all you care about in an entity set is just whether it has it or not. And then similarly, the iterator is a little bit different, right? The iterator return value in the entity set is just the list of entity IDs, whereas the component tables iterator will return this tuple of the entity ID and then the actual object itself.
Nice. Okay.
Similar logic. Yeah. And the reason why I did that, I made that common interface, is because I can basically stick all of these things into a type safe container that's here, that's private. And so you'll see that we have this like hilarious thing here. So anytime we add one of these things, we just need to make sure that we add it here, here, and then in this thing. But then it makes things like deletion really convenient, right? You can just iterate over them and delete out of it. And then when you want to roll back, you can just roll back this way. And
That's
then
great.
Similarly for commits.
Yep.
The only thing you can't do currently, because I haven't really figured out a nice way of doing this, is registration still requires all of this boilerplate. And that's because when you register a new entity or like these set of components, you need to kind of like line up the thing that you're checking with the container that you're putting it into. And you also need to make sure that these are type compatible, right? The hitbox component table can only take a hitbox component, right?
That makes sense.
Yeah. And as far as I know, there's not really a great way of doing that in a loop.
Not that I'm aware of. Cool.
Yeah.
So the entity set, it doesn't have an update either. And that's probably fine because we actually don't have a single property that changes that way. Is that correct?
Yeah, the component table doesn't have an update either. Oh, you're right. You're right. Yes. You meant update as in like modifying state.
Yeah. Like we can update components, but there is no. Is there an add in entity set?
There really is just removing, right?
Okay.
Yeah.
That's what we have right now. I think that makes sense.
Yeah, and I think the delete implementation is going to look very, very similar between these two things. If not, it's not 100% identical because with deleting out of the component table, you need to make sure that you snapshot the old value before you get rid of it, right?
Yep.
The entity set, you don't really care. So I ran into this interesting thing that we will have to solve some way. We talked a little bit about last time, but it's about our indexing. And now our indexing is like true indices, where it's not like source of truth data that are in the indexes. It's actually just like optimization stuff, right? So when we index, we have this list of friendly teams. This was necessary for some reason. And then, of course, we have the big index, which is the quad tree, right? Our spatial index. Right now, when you index an entity or you unindex an entity, it just basically says, well, for all of my indices, I'm going to like pull out the relevant information out of whatever component table I'm interested in, and then index that, right? And so we do the same thing with like transforms in the quad tree, right? So what's interesting about this is that currently we don't have a mechanism of subscribing these indices to the component tables that they are interested in. So when you update a transform, it doesn't reindex the quad tree, right?
That's interesting.
And when you roll back the transform table, it doesn't update the quad tree either, right? Or at least it doesn't do it automatically. So the upshot of what I'm getting at here is that, or the sort of punchline of what I'm getting at here, is that like we still need to keep at the entity manager level this concept of predicted deletes. which is a problem that I couldn't solve right away, or I didn't know how to solve. Let me bump the font size real quick. And maybe you have an idea about how to deal with this, but basically, when we,
I guess this is our mark for deletion at the entity manager level that does get sent to every entity state container, but the entity manager is still having to keep track of this one piece of cross-cutting state.
Yeah, we have to basically keep track of this predicted deletes and also predicted registrations as well, I believe. Because the entity manager currently is the only thing that knows what got created and deleted, registered and deleted rather, so that it can update these indexes, right? So it's a bit of a weird transitional state right now that we're in, where the individual component tables themselves take care of most of the rollback and commit logic that multiplayer requires, except that we still have to do this stuff.
Would it make sense to pass the index functions in to like an entity state container, like to have a component table know how to index on update? Like basically taking that function and passing it, putting it down a level.
You could push it down a level. And so are you saying that like we'd put it here?
Well, and basically it's like it's only on the like we have two indexes right now, which is transform and team. Yeah. So like basically giving the transform and team containers a function, just some sort of thunk that they can call in their life cycle.
Yeah, totally. So you're talking about hooks, basically, right?
Yeah.
So basically,
or some sort of just inject this function.
We'd have an update hook. We'd have a rollback hook. We'd have a commit hook, right? That's a really good idea. I had the idea that I had, which I think might be just kind of like isomorphic to the one that you're talking about, was to make the component table an event emitter. In the classic JavaScript style, you just emit an update event, you emit a rollback event, you emit a call. I can't talk today. A commit event, and then you listen to those events inside this constructor, and that's pretty much equivalent to passing the callback down, right?
Yeah. You've mentioned that a couple times. Switching over to an event emitter infrastructure, that's probably a bit of a restructure for us right now, but
yeah. And I think games use event emitters in all kinds of different ways. This would definitely be a relatively limited kind of like internal piping sort of way. To the degree that maybe it's better to just pass in a function to do it. The thing that I haven't quite figured out how to deal with yet is that I feel like the indexing piece, you might want to do it after every table has updated.
Interesting. Not...
Well, it just depends. Right now, we don't have a situation where a particular index... Where is my indexed entity? Index. I think both of our indices are dependent on a single component right now. And so we're lucky in that all you'd have to do here is basically put your hook on the teams table to update the friendly team index, and then put a hook on the transform table to update the quad tree, right? If there was an index that depended on two different tables,
that'd be interesting. Yeah.
What would you do?
It's a good question. And also the your point about it having to happen after the update is really important. If we update transforms mid-cycle and someone queries the quad tree after that, they'll get a strange, unexpected result.
Potentially. I mean, you may actually want to have the quad tree updated, right? Like we always had this issue with the quad tree where our moving objects don't exist in the quad tree, and they don't because we didn't figure out how to update the quad tree, or we were worried about the performance of that operation, right? But if we did make it transform, like if we gave it a hook or we gave it like an update event or something like that, the quad tree could listen to those things, and that would be one way of implementing that, right? And in that case, maybe that's a situation where you do want the quad tree to be basically being updated in lockstep with the transforms, right?
Interesting. I guess.
Yeah.
I was thinking for one tick of the server, would you not want everyone's transform to be? Well, no, I guess you can. If you update a transform and you go and check the transform component instead of the quad tree, you'll get the updated value too. So
yeah,
that's not a real concern. Okay, cool.
I think, yeah, I think I see what you're getting at. We do have situations where like the tank mover, I think it's updated before the wall collider, right? And so the wall collider does have like the new value of the transform after the tank mover has applied its logic. Right?
Yeah, but if it looks at it, like, yeah, the quad tree would actually be out of date if we hadn't updated it at that point and the tank was in there. So
yeah, exactly.
Okay.
The thing that I'm not quite sure about is like, you can imagine a quad tree that is also hitbox aware, right? Because like right now our quad tree insertion works because we assume all hitboxes are exactly the same size, right? But if your hitbox changed its size, you'd also want to be listening to that as well, right? And so if you had, I guess the thing is, quad tree is an example of an index where any kind of dependent state that changes, you'd want to know about it right away, right?
Yeah. Could we?
I was trying to think of it. Sorry, go ahead.
No, that's for sure. Oh, or I was gonna say, are we only hitbox aware? Hitbox. The only thing that's locking us into being tile bounded is line 292, right? We could actually take the hitbox and put it in the quad tree, and then we have hitboxes.
Correct.
Okay.
Yeah.
Like it's not.
Yeah. We just
didn't do
need to
anything
change the
structurally
entities
wrong.
AABB basically. Yeah.
Great. Okay. Sorry.
Yeah. No problem. So. I guess what I'm saying is that like right now we basically both of these indexes really only need to get updated on entity creation and entity deletion, which is actually what's happening right now. And the reason why that's the case is because your team never changes currently.
Yep.
And we don't put moving things into the quad tree.
Correct.
Right. So one way we could do this is we could have the callback hooks that you were talking about, or an event emitter. Either of those, I kind of see those as like basically equivalent implementations, right? But we could maybe make a new component table or maybe a new entity set that is, sorry. That's literally just like the set of all IDs in the entire game, right?
Oh.
And what this would do, what we could do is we could attach listeners to the rollback and commit, or add and delete on that thing, and then we could plug the indexing functions onto that thing, right? And
that's clever, yeah.
What that would give us is basically we don't have to take care of this in the entity manager, which is basically how I started this whole conversation, right? It was like I was kind of like, this is the one weird thing that we keep having to like keep around. Like we have to keep around predicted registrations, and we have to keep around predicted deletes because we need to like index and unindex. But if we put that into a component table that can emit events, then we might not have that problem. Right? Does that make sense to you?
Yeah. Yeah, this is going down the event emitter path, but I like the way all entities... I mean, it's interesting because once you go into the all entities entity set, the thing about that feels like also just having the entity manager manage it. Because it's only used like kind of for this thing, right?
Yeah, it's really just used because we need to index and unindex.
It's like a private entity set, yeah.
Yeah.
Okay.
Oh yeah. So you're exactly right. This would probably be private.
Yep.
Right. Because nobody else really needs to know about it. I think.
I mean, I don't want to give people the power to loop over everything if possible. So.
Yeah. But anyways, I just want to throw that idea by you. We don't need to dive into the details of that.
Yeah. No, I like it. That makes sense.
Boy, I think this will be relevant to our multiplayer conversation. Maybe this is the last I'll ever say about multiplayer until next week. But we eventually want to get to a place where the quad tree is getting updated on every move, or else it's not as useful, right? But
I agree.
The problem is that like anytime we create a new entity, we have to like unindex it like 15 times, right, out of the quad tree, because its creation will get rolled back until the server actually acknowledges it, right?
I guess I was wondering too. You've mentioned. I guess we've thought about having different quad trees. Like I wonder what the bullet quad tree would be like, and if we could sort of set it up with different semantics. I don't know. The 15 rollbacks are unavoidable though. That sucks.
Yeah. Yeah, I guess this is like the classic, why doesn't every database work this way? Like, you can't just instantaneously, like, time travel a database back in time. I guess you can, right? Like, I guess a lot of modern databases that you pay for, you can do point-in-time restores. But I wonder how they handle indexes, right?
Yeah.
Like, maybe they just back up the index data as well, right? They just literally keep a copy of it.
That would be the brute force solution and pretty nice. God, what's
Yeah, it actually, I mean, now that I say it out loud, like, what if we just had 15 quad trees, right?
I've been wondering if we could get away with, it'd be interesting if we could, I feel like we don't have a memory problem. I feel like we have a CPU problem. And we haven't,
right.
Like if we actually wanted to keep more state in memory, I think we'd be okay.
Yeah.
Because if it's permanent state, it won't be churn. Or if it's like a rolling window, yeah.
Yeah, it'd be a rolling window. Although, like, how we shuffle things off the front of the window and put it back on at the back of the window, or vice versa, we might need to be a little bit careful about the way that we do that, because each one of those views is like the full state of the world, right?
Yep.
Or some major horizontal slice of that. And when we tried that originally, like when we tried to do this multiplayer implementation originally, we were deep cloning the entire entity state, right?
Yeah.
Every frame. And that got us in the garbage collection trouble, right? Or at least it was costly to do the clone.
Yeah, that's a good point.
Yeah. Well, I mean, I think that's no reason to not explore that idea, though. Like, we could have just been wrong about the way that we went about it, right?
It's hard to say right now.
Yeah. All right. Well, anyways, that was a lot of babble about like what changed over the weekend, but I think that's basically the state of it right now.
Nice.
I will propose that we don't necessarily solve any of these problems right now. Maybe come back with fresh brains about it in a week.
I'm with you, yeah. And I think I'd like to revisit at either after the next session with Steven or a future one, actually digging into our timing functions, because you were putting some stuff out there about how to actually measure performance and figure out what our slow parts were. And I was a little sleepy at that moment, and my brain was not catching up to you. So I would love to like go back to that and actually instrument our shit. Yeah.
Right. I don't even know where I was going with that. So I was probably just as sleepy.
Quite possibly. It was definitely like
I heard you say something. I just heard you talking right now. I'm like, I don't even remember what I said.
That's great.
And when I said it. Yeah.
Well, I bet if I try to start timing a function again, it'll pop back into your head. So we can try that approach for remembering it.
Right.
But you had a strong opinion, so I want to go back to it and make sure we measure the right thing. But after the multiplayer session.
Yeah. Okay, so if we want to do graphics, do we want to change the entire look and feel of the game, or do we want to try to re-implement the game using like WebGL?
Ooh, that's a great question. Yeah.
Either way involves WebGL, but like what's our first step?
Yeah, I was thinking it'd be super interesting to take this and turn it 45 degrees and render boxes and circles for the current map. So like replacing the renderer and sort of replacing our renderables. Is that how you would approach that? So maybe
yes.
maybe I'm saying keep the look and feel. We'll just do super primitives until we can think about modeling later.
Okay.
Yeah.
And so are you saying we'll continue to write 2D? We'll continue to render in 2D using 2D drawing algorithms.
Oh no, I was thinking we go to 3D.
Okay.
Yeah. So if we started in 2D top down and then wanted to move the camera, that would also be pretty. We would suddenly be empowered too.
Yeah. Okay, that's actually a really interesting thing, and that's I think more than it would be more than 2 streams worth of work just to replace this exactly what we're seeing right now using WebGL. And I'd be actually morbidly curious what the performance contrast would be.
I wonder too. Yeah.
Yeah.
What was your thought for approaching it, or did you have a vision in mind?
I did not have a vision in mind,
Cool.
but I think the one that we're proposing here is a good one.
Sweet.
Okay. Well, let's do it. So we have a renderer. It's actually a reasonably walled off interface at this point right now. We have an iRender interface where we can clear. We can set a transform. And when do we actually use the set transform? We use it a lot. Oh, and this is essentially what coordinate system are we using, right? Are we using the coordinate system of the UI, which where like this coordinate here is probably like 10, 10, right? The top left corner of the energy of your health bar. Or are we using the coordinate system of the whole world, where 10, 10 in the whole world is all the way up here?
Exactly.
Right?
Yeah.
Yeah. Okay. Sorry, I'm just teaching myself how our renderer works again.
No, I need the refresher.
Set global opacity. This might be something we'll have to kill. We'll see.
I wonder too if we would actually just if our UI could be a 2D renderer on top of the WebGL.
Yeah, and in fact, set global opacity is really just for the crosshair.
This was for we were putting transparent objects.
Oh yes, we're putting transparent objects because of the builder system. Right?
That feels like it's not actually part of the 3D interface.
Yeah, I don't think so either. We can deal with that later. And then I keep losing the window. Oh, it's under interfaces. This is a cookie file. Because I think it's all render. Oh, it's renderer
interfaces. Okay.
Okay. I would have just thought this file would be called renderer. And then we have a render which renders these things. But I think because we have like a kind of walled off interface, we could do a Canvas 3D render with probably not a huge amount of effort. So I guess the question is, how do we draw squares, and how do we draw circles, and how do we draw lines in WebGL? Right? And that's basically what we're going to have to do.
Let's find out. Yeah.
Okay. All right. So we're going to be just plumbing the depths of the WebGL docs. MDN it is. And I think for our purposes, we'll probably want to try to like prib as much as we can.
Mm-hmm.
They have
Huh.
WebGL 2. Oh, WebGL 2 is like just the version 2. They don't mean 2D.
Yeah, but we do want WebGL 2 because it's probably better.
I guess it is. So let's start our render.
And is it still a canvas? It's still inside a canvas, right?
Yeah, it's still inside a canvas.
That's wild.
And I guess this
duplicate
is
this
context 3D. It's probably going to be rendering GL context.
In the MDN, I see WebGL2 rendering context as the interface.
Yeah. Oops. Oh well, we don't need the browser for now, right? Just wanted to close. I wanted to close it to basically stop it from eating my CPU.
Ah, yes.
WebGL2 rendering context. Well, do you need the browser for doc? So let me grab another window for that. In fact, how do I do that? It's gonna pop over anyways. Okay, and the transform is our global transform, right?
I guess your original question was, should we implement WebGL 2D instead of what we have?
Yeah, and do they make a distinction in the API?
That's what I'm wondering. It says at the very top there's a 2D. There's a mention of 2D.
2D and 3D graphics for the web.
And it says the canvas element is used by the canvas API to do 2D graphics, but like, isn't that what we were doing?
Yeah.
Okay.
I'm not sure why they're adding 2D content to WebGL context. We still need shaders. Right.
Okay, this looks, yeah.
Yeah, this is fine though. Okay. So this is going to be quite the adventure, I think, which is fine.
It's great. Hey man, it's not multiplayer.
It's true. It's true. This is just a simple matter of programming. Like, this is just like a really long API that we have to kind of fight through. Right. So maybe the first thing that we can do is to just maybe just get the renderer to draw like a particular color.
Yep.
Into the canvas, and that'll be a big victory. Like,
Yep.
If we get to that today, that'd be amazing, right?
I think that's probably right. Yeah, I was thinking like, yeah, do we want to draw a plane? And that sounds about right.
Okay, so
moving
we
the camera
need
around that plane might be too hard.
Yeah, we need to actually send a GL context in there, and
I mean, we're sending the canvas, and
is it index.html that we set this up? I feel like it was main.tsx.
You were just looking at, yeah, so
send the canvas in there. Okay, got it. And then the client. Should this API be passing in the canvas instead? It feels like it makes a lot more sense, right? Well,
yeah,
at any rate.
Then we can swap this out a little more easily. Oh, there you go.
And WebGL2 is the name.
I like it. Yep. And sorry, were the other versions there? One of them is WebGL or experimental WebGL.
Yeah.
Okay. Looks like we're using the good one, so. And or the experimental one that we have to turn on support for, but that's fine.
Yeah. Okay. So if we can get this to just draw one color, I think that'll be a big win. So let's see if we can do it. I would say all the rest of this stuff is just going to do nothing, right? In fact, why don't we just comment it out?
Yep, I love it.
Did I?
Yeah, you got it right, actually.
Curlies. Okay. Okay, so how do we clear the canvas?
Oh, we're still adding 2D content as well. Oh, but I saw create the square plane. We probably want to do. We want to actually clear it in 3D, right?
Yeah. WebGL WebGL2 rendering context. We either draw like one giant quad, right, to screen space. That could be what we could do. I don't actually remember if GL has an actual like clear function. That seems a little bit too high level, right? Let's just see. WebGL clear screen. Clear color.
Cool.
And then the color actually can't be a string anymore, right? So this is actually an interesting.
Oh gosh. Okay.
Well, let's just ignore the color. Let's always just set it to something that we decide, right?
Yep. Sounds good.
And clear color is red. It's just RGB, right? What's magenta? Is it 1.0, 0, 1.0, alpha, and hopefully alpha is G clamp F. The hell is that? Clamped float, probably, right? Clamp 32-bit floating point.
And then we ctx.clear.
Clear depth. Did we talk about the depth buffer before?
Briefly, but I do not recall.
I need a mask. We'll keep this in here because I think it'll be easy to forget about, but we won't talk too much about the depth buffer tonight.
Okay.
It's basically how you can, in 3D, make sure that things that are closer to you get drawn in front of things that are further back without having to do the sorting yourself.
Oh, neat. Okay.
Yeah. What it'll basically do is you basically have two different buffers representing your screen. One is the color buffer, which is the one that we're clearing, and one is the depth buffer, which is all the Z values of the pixels that were currently written into the screen, right? Like how far away were those pixels?
Oh, that's neat.
And then when you draw like a new object, what it'll do first is what's called a depth check and say like, what's the Z value of the pixel I'm trying to draw right now? And if you check the depth buffer and there's something in there that's closer than the Z value that you're trying to draw, you just won't draw that pixel. Does that make sense? Yeah. Okay.
That's really clever.
Yeah, it's nice, right? Really nice API. GL. Oh, we can actually clear them together, so I don't even need to do this separately. I can do this, and I've never done anything with a stencil buffer before, so we'll learn together what that actually means. And I think GL. Do we simply do this? How do we get these cons? Yeah, boy, that's
really
a very long. Yeah. These are where all the attributes are. I think are listed now.
Okay. We could redefine that ourselves if we wanted to.
We certainly could. So I think maybe as an example, we could. How do we rebind this?
Is it?
We just say const GL equals.
Is it a type though? Because is it type GL equals WebGL to rendering context? No, maybe not.
Can you say it again?
I was thinking it'd be a type, not a. Just that we'd have to be in TypeScript, not that we could do a const. But it looks like that took it. Oh, now I'm not sure.
Yeah, because class names are consts as well, right?
Yeah, no, it's one of those things that's actually, I guess it's in both namespaces.
Yeah. Is it weird that the type is this? It is, right?
Yeah. Okay. I think const GL, I think you were correct.
What's that?
I think we need to keep.
This?
Yeah. Yep. That's what was confusing me. I was just like, we can't use this as one value as both, and there you go.
Yeah. Or it's fine that it's a type.
I didn't mind it as a type. Yeah.
It's an object. Yeah. So maybe this can go back to being matching what the docs say, right?
I think that'll help us out a lot. Yeah.
All right.
Okay, so that should draw magenta?
That should do something, right? Canvas 2D render is defined but never used. We just need to import this. These are a bunch of just warnings. Is this going to complain if I try to compile?
I think you should be able to run it.
Okay, let's just run it.
What is our camera about to do?
Our camera will do nothing because I think the camera basically just sets the transform. And that currently just doesn't do anything.
Great, right. So we're clearing the buffer. It's in the canvas. The canvas
so
is
this
taking
should just
over
be
the
a
whole
magenta,
screen.
right? And if I change this to, let's make it slightly less red, right?
Eventually, we expect this to hot reload in there.
Yeah, the hot reload should be working. I thought I turned it on.
Didn't even rebuild. That's weird.
I might have broken it.
Oh, maybe because there's a bunch of errors in the...
Let's check this out. Let's see. Ah, that'll be useful, right?
What's that?
I just didn't enable the hot reload.
Oh. Ooh, I think your video might have lagged out there for a second because I did not see you change that value. No. It's no, you're good. This Discord and Mac, this experiment might be no better than Zoom.
A little tricky. Yeah. Okay. So we
know
that the code is working, but
nice.
Let me go ahead. Actually, make the code a little bit smaller. Is that okay? Now let's actually just test the hot reload here by changing the clear color.
Sounds good. Jeff, do you want to comment out start game so it doesn't start the simulation loop as well? I feel like we can buy some CPU cycles back while we're just rendering.
Yes. Or I can... Okay, that works. Well, when do we call clear, though? We call clear in the game, right?
It must clear before game, though, because when we're waiting for the server to pick up, it definitely is already magenta.
Yeah, we can come in at the update. The renderer will clear, right? But the problem is that we actually need to start drawing things.
Yep.
Right? So we do need the simulation.
Yeah. Okay. Fair enough.
It's too bad. Well, I think what we could do is maybe
tiny map?
Turn the server update off.
That too. But do you want to go back to the map that is super performant?
Oh, that's a great plan.
Yeah. Yeah, that'll help us out too.
Server?
I think it's one of the few things. It's still in game TS. It's like the actual levels are in game.
Oh yeah, good call. Collision test, was it?
There's actually the one that is tiny map is actually a 8x8
test.
Quadri test. There you go. That's the 8x8 grid. Collision test is the full 64x64 with a bunch of blank.
All right.
So Quadri test actually is a good one for us to do like variable sized maps and like have the camera focus on the right spot too. We had issues with that in the previous renderer.
Yes.
Mostly because we never tried to fix it.
Yeah. Hopefully that's better now, performance-wise. I don't know for sure. In fact, we basically just need this. Okay, so now we actually need to know how to draw, let's say, background tiles, right?
Mm-hmm.
Or do something with text, maybe? Maybe text is easier because we don't have to worry about the camera.
Mm-hmm.
All right, let's get back to magenta real quick.
Are you doing stuff? It is just, I'm getting like 1 FPS over here.
Sorry.
No, I mean, WebGL might have eaten all the stream. That's an
WebGL is eating the stream.
That's an interesting problem.
Yeah. Can you see me doing anything right now?
No.
That is an interesting problem, isn't it?
Yeah. Turn your camera off real quick too. I think there's still a placeholder for that.
Yeah.
Oh shit.
What's up?
Zoom just Discord just sort of resorted where the cameras were, so like now the picture of you as a goat is the is the big screen. Because it put it where I was getting your screen share from.
Oh, no. So Discord resorted everything.
It just resorted. Yeah. I'll fix it real quick while you're doing stuff. I can see you actually typing now, which is great. It is an improvement. Okay, so camera's bullshit is good to know. I guess we could like call in from separate devices too if we're having camera CPU issues.
Are you seeing this website that I'm on right now?
Yes.
Okay. This scroll bar on the side.
Oh no, I hate it.
Why would they do that?
Boy, just because that web API is available does not mean.
Yeah, and they're
Oh boy, look at this.
Their header does this cool thing with the mouse cursor.
That is a cool thing.
So I already ran into something that's interesting and challenging, which is that apparently drawing text in WebGL is really difficult. I do wonder if there's a reality where our debug render actually is still the 2D renderer.
Like our text output, frame rate, that sort of stuff.
I'll potentially even line drawing as well, maybe.
Well, we might have trouble doing line drawing in 3D from that.
You're right. You're right.
But text in UI, I was thinking would be the 2D renderer for at least what we're using. That seems legit.
Yeah. Well, in that case, let's not start with text. Text actually proves to be the hardest thing because basically your 3D rendering pipeline just doesn't have the ability to do text.
That does make sense.
Yeah. So what I think a lot of people do is they'll make a bitmap font and they'll basically render that font to a texture and then apply that texture to geometry. Yeah.
That's really clever.
Yeah. All right. So what we actually, the reason why I wanted to do text first is we had to deal with, I didn't want to deal with camera stuff, but we're going to have to just like jump into the camera stuff. We're going to have to just get down and dirty with it.
Let's do it.
Okay. Okay, so I think the camera interface ultimately just sets the transform. And the transform takes a world coordinate and converts it into a view coordinate. And our view coordinate is basically the origin is the upper left corner of the screen. But I think in 3D land, the origin is the middle of the viewport.
I have an important question.
Yeah.
Is our game going to continue to be a 2D plane that we're rendering in 3D? We're not changing our coordinates to vec3s, essentially.
I
think that's at least the same game, right?
Yeah, like the game simulation can still be in 2D.
Great.
For
yeah,
sure.
Yeah, okay.
Yeah.
Just making sure.
Okay. Okay, so we do need to actually still do our render here, right? But this time, what we want to render is just the background stuff. So maybe we should render rectangles. How's that sound?
That sounds great.
Okay.
And so you were saying about the origin. I think actually 0, 0 is the center of our screen too in the 2D renderer.
Is it?
Yeah. Maybe you did that out of foresight. Because we do handle that. Like the top left corner is like -500, -500 or something when you put it in pixel coordinates.
Interesting. That's actually not what I would have expected. But it could be just the way. It just depends on what the rendering context expects, right?
Can you open up the quad tree test map? Actually, I think it might be that we set the coordinates there to. Yeah, JSON. It's the origin. Okay, that's why. We did it to ourselves in a happy way, I guess.
So this is the map origin, but what I'm talking, but what the renderer cares about is like, what is 0, 0 when we're talking about screen space, and that's what the renderer decides what that is. We don't get to decide what that is.
Oh, I see. Okay.
Does that make sense?
Yeah. That's right, because we had to convert that top left corner that is negative to actually 0, 0 when we put it out in the renderer. Okay, yep.
Yeah. And so I'm pretty sure that like in the Canvas 2D API, the upper left corner is the origin, whereas in WebGL, the center of the screen is the origin.
Is that nice for us because we actually have our coordinates in a place where they're already sort of more correctly mapped to that?
Yes.
More or less.
So right now the camera is providing the transform. But does that mean that the camera needs to be aware of whether we're rendering into WebGL versus the 2D API? I mean, it's not. We're going to do one or the other. We don't have to have it support both, right? That doesn't make sense.
Yeah. If our camera is moving is like locked on a 2D plane in 3D, maybe we can keep it the same. If we're doing like isometric in this fixed perspective.
Well, if it was isometric, the camera would have a lot of different things, a lot of things that are different about it, right? If we're rendering isometrically, the camera.
Right. Okay.
It depends on what we mean by isometric. Are you talking about isometric in terms of like we have 3D geometry and rendering isometrically, or are you talking about like your vision of just like a Final Fantasy style isometric where it's pixels?
I guess I'm thinking 3D geometry rendered isometrically.
Oh, okay, yeah. So in that case, the camera will be a bona fide like creature of the 3D world.
Okay, cool.
I think, yeah.
Sweet.
Yeah, because it would be positioned like some distance above the ground, right?
Right.
Yeah. Okay. None of this matters a huge amount. I think what we really care about, though, is that we want to just make sure that, like, when we get this transform, we're doing the right thing.
Mm-hmm.
Now, interestingly, the renderer doesn't know how big the screen is, so that's kind of like relegated to the camera. So or delegated to the camera. So the camera kind of has to know whether or not the screen space origin is the center of the screen or the upper left-hand corner, right?
Fair.
Yeah. At any rate, let's try and just draw something, right?
Cool.
So we want to do a rectangle. We have a fill style. We have a stroke style. And what is our fill style? Like, how are we? These are strings, right? And I think our models are just saying black, red, whatever.
Yep.
And I guess one thing we could do is just have a color table, right?
To get it to translate that for us pretty quick, yeah.
Yeah. And what are our other colors?
We've got green and yellow and like a couple varieties of tree green that we're not using, and then a gray.
Okay. What is yellow in RGB? Is it full red, full green?
I think it's full red, full green, yeah.
And how many different greens do we have?
We have the tree has like some random jittering on that, I think, or maybe just a couple colors in.
How did we jitter the color? Do you remember?
I think, is there a tree renderable?
Yes, we have green, forest green, and dark green.
There you go.
Okay.
I mean, we don't need that right now, right?
Not 100%.
Yeah.
Although I'm just curious, if it's out there.
Fair enough, yeah. The other thing will be brown and blue for the water and the mountains. We need those for the tiles more than we need forest green for sure.
Blue is just straight blue, right?
Mm-hmm.
And then brown?
Brown is, yeah.
Brown in RGB. Is that really what brown is?
Interesting.
I guess brown has no magic combination that's like pure.
Yeah,
right?
it's like mostly red, little green, little blue.
Yeah, 0.65. Something like that.
Sounds good, yeah.
And let's just say that our greens are all good. Drawing circles would be hard anyways for the trees.
We're not gonna. I don't think we're gonna get there. So yeah,
Yeah,
that seems good.
Okay.
By the time we get to that, I hope we have like a better color system where the models are 3D models.
Exactly. Yeah. They're not formatting. Why do you hate me? I'm having a hard time deciding when this knows to apply prettier. Do you know what I mean?
Yeah.
Because it knows.
That's so weird.
All right. So how do we draw a colored piece of geometry? WebGL, draw a square. And it's going to be a ton of code, just so you know.
Nope. Yeah, project time, 2 to 3 hours. I love it. That's always my expectation for GL.
Yeah.
We got that.
We need to set a viewport. We need to do a clear color. We need to clear the viewport.
Oh, that's, yeah. Did we get past in a canvas here yet? We didn't.
Let's get a canvas.
Yeah, that'd be nice. Canvas?
The client knows what a canvas is, right?
It makes a new
HTML canvas element.
There you go. Boom.
We're just going to do all of our initialization here.
Yeah, seems great.
All right. So what does the GL viewport function do, right? I'm assuming that WebGL 2 rendering context is mostly the same API, with probably some differences.
It seemed like it was the difference between OpenGL 2 and OpenGL 3 and some, yeah API abilities.
This is interesting. A GL int specifying the horizontal coordinate of the lower left corner of the viewport origin. The default is 0. Lower left corner of the viewport origin.
Lower left?
When you first create a WebGL context, the size of the viewport will match the size of the canvas. However, if you resize the canvas, you will need to tell WebGL context a new viewport setting. I don't think we need to do this. We're not worried about resizing just yet, right?
Oh, and we've created the canvas, so it actually is great.
Yeah. I'm commenting this out for now. I don't want to add code that we don't need. Does that make sense?
I'm with you, yeah.
Okay.
Do you want to revert the entire canvas change? I do feel like we'll want the canvas in this later, but
I do feel like we'll want it as
okay,
well. I'm okay with that being there.
Great.
That feels relatively. I feel like this should just take the canvas anyways, because there's no reason why the client should know what the rendering context is, right?
Yep, totally.
There's no reason why we should be doing this line of code there. Boom.
Sweet.
Okay. Did I lose my... Oh, I'm in incognito. WebGL. Draw. Okay, square. And a lot of these tutorials are going to have like a lot of superfluous stuff. I feel like I recognize this, actually. We clear the background. Oh my god. this.
So
Web
many
page.
ads.
I regret it already. We need to do a shader.
Sweet.
Let's just fucking do it. So our vertex shader will look like this. It'll be 2D vector with the vertex position, and then it will output a position in screen space, right? So the input is whatever space the program wants to provide, and the shader's responsibility is to emit a screen space position. And as we can see, what this is doing is it's just emitting a 4D vector with the x the same as the x position of the input, the y the same as the y position of the input, a 0 value for the z, and a 1 value for the w coordinate. We'll not get into what the w is for now. When we do actual 3D stuff, it'll matter.
Great.
Yeah. Const vertex shader. Isn't this exciting?
We did it.
We wrote a shader, ladies and gentlemen. It's done. Const Fragment Shader, also known as the pixel shader. The Fragment Shader takes a particular color of a particular pixel, and then based on other parameters that it has access to, will change the color of that pixel. Or rather, it will take parameters and a coordinate of screen space and then emit a color, right? I'm not convinced that we need that. Let's just try this. So what this is saying is that there's a uniform. A uniform is basically a constant that is set at the level of the entire renderer. Does that make sense?
Yeah, we've encountered that a little before, I think.
Yeah, so more or less, a uniform, like a renderer is a giant state machine, right? It's basically modeling the state of both what's going on in the GPU and also stuff that you've interfaced with in like your regular program. And either your input to your shader is an attribute, meaning that it's like basically per vertex, this value is going to be different. But in the fragment shader, you don't really have that same notion anymore. You have uniforms, and uniforms are just values that you set on top of the renderer. So you basically say like the uniform foobar is black, and the shader will just read that.
Interesting. Okay.
So as you can imagine, if you change the uniform a lot, like if you change it like once per pixel, that could be really expensive, right? Because you basically like the point of using a GPU is to run this in a parallel fashion. But if it has to wait for the CPU to like set the uniform differently every single time, it'd be pretty slow, right?
Interesting. Okay.
Yeah. Yeah. But what we will find is there are ways of attaching colors to vertices, and that will set like a kind of default color per pixel that it'll know about going into it. So you could also just set it to that, right? That's why a lot of demos of 3D graphics are like triangles that are color blending from red. Like one corner is red, and one corner is blue, and one corner is green, and it kind of blends between magenta and yellow in the middle. Basically what they're doing is they're saying, one vertex I'm gonna set the property that is blue, one vertex is red, one vertex is green, and the default behavior of the renderer between the vertex shader and the fragment shader is to interpolate between those. So the pixels in between the coordinates will be like a blend of an average of the three colors. Yeah.
Okay.
Yeah, that's just the default behavior.
That makes sense. I've seen that a lot.
Yep. In fact, that's kind of maybe shades of red and blue. Like shader almost feels like it comes from that behavior, right? Like what shade of red, what shade between red, green, and blue is my pixel on this geometry right now?
Interesting. Yeah.
Yeah.
Huh.
Okay, so not only do we have like programs within programs, right? The shader is just a piece of code that gets compiled and then run on the GPU.
I'd say, and we're actually taking this like a string and handing it as something else is going to eval this from a string we made in JavaScript is what is happening.
In fact, basically gets compiled, and the driver is your compiler.
Okay.
And it does this at runtime. As far as I know, at least the way OpenGL works is just this, like you can never like pre-compile these things, which is always a little bit strange to me. But I think maybe that makes a little bit of sense because maybe it expects that your executable is going to be running on different hardware and with different drivers, and the output of different drivers might be different GPU code, right?
Interesting. Okay.
Yeah.
Oh, and yeah,
there's
have,
like
the
different instruction sets. They all do different stuff.
Right, and here it is saying compile shader and compile shader, create program, attach shader. Okay.
Yeah. Okay, so let's do all that.
I have used this boilerplate before.
Yes. Does it kind of look familiar to you?
It looks really familiar. Yeah. Did we lose GL? Oh, because this is our context, right?
I mean, we could just use this .ctx for a lot of these. It seems weird. I'm not sure what I prefer. I'm going to keep going with what we've got, and then we'll see what happens.
Okay.
VS. This is just the Vertex Shader. And V. What's V? V is their string value.
Wait, so we needed that value. I think.
We did. Let's call it VS. And so what I'm going to call this is
Yep.
The shader is the actual kind of like object.
Yeah.
And it binds the source to it, and then it compiles it.
What is TypeScript?
Create shader or null. Is it just
bang? Bang.
Why could this possibly return null? That's a weird API. I don't know. And I bet the Fragment Shader is the same thing.
Yep. Boom.
Yep. Fragment Shader. That's the source of the Fragment Shader. Okay, so now that they're compiled, this is like equivalent of like just a bunch of .o files sitting on your hard drive. Like if you compile a C program, it's not doing anything. Right?
Yep.
So we actually have to attach it to a program and link it. It's a bunch of C programmers that put this together.
Since we're in Parcel, we can actually... Do we have OpenGL files as a first class import? I think we do. For future us, we don't want to do that right now, but I think we can just import .OpenGL.
Yes, you're exactly right. So with Parcel, we could put these shader files into .glsl files.
Yeah, that's it.
And all that really is a text file. So when you import that file, you just assign it to a variable, and it's the same thing as what we're doing here.
Oh, exactly.
Exactly.
I just, for some reason, like I always prefer having that sort of like first class import over like sticking it in a string. And I know it's still a text file, but like I love that something is doing it for me.
Yeah. That's totally understandable.
Yeah. I don't know why that feels safer, but it always feels safer to me.
Well, I mean, this is messy, and this will get potentially more complicated when we're doing more interesting things, right?
Yeah, maybe it's like if we installed the VS Code GLSL library, we'd actually get like some syntax highlighting and some like rough checking of some sort, which would be cool.
So in the modern day, you can imagine that you're actually varying your shader and your vert and fragment shaders like constantly, right? You're changing them for different pieces of geometry, all that kind of thing. And the way that you actually compose these is actually going to be maybe in like a graphical interface.
Interesting.
You may like do kind of like, well, I want like all these different special effects on my vertex shader, my fragment shader, and you may actually compose it using like a visual editor. And so the representation of that visual editor is not GLSL source code, right? That visual editor probably needs to like crunch that down. So you could even imagine a higher level shader representation that's maybe a little bit more declarative, or maybe it's a DSL or something like that, that would get crunched down. So you may not even have access to the raw GLSL of your shader, depending on like what your engine is telling you to do, right? Your engine or tool chain may just, the thing that you access is actually something much higher level than this. Yeah. Now, this isn't the lowest level that it could go. Obviously, this is the interface, the common interface that is defined by the OpenGL standard. If we wanted to get real crazy, we could just be writing like GPU machine code, right?
No, thank you.
Yes.
I've written assembly before, and I do not want to do it again.
Yeah. Okay, so now we're just binding these .o files to an actual program. And then we link it. Now that we've linked the program, I don't know if it's actually saying use the program. So that's actually something we should keep in mind. Does this automatically say that this is the shader program that is like sent to the GPU or like loaded in our driver now? Or is it just a thing that's just in a database somewhere in the driver, right?
Yeah.
That's not being used yet. We don't care about debugging right now. The native coordinate system. Yes,
Boom.
The center of screen space is 0, 0 to
Called
-1 to 1, 1.
You were correct.
Yeah. Okay, so one thing I want to point out to you that's interesting, and this may be a bit of a refresher for you, is that do you notice how like the width and height are both normalized to a range of -1 to 1? But the aspect ratio is actually not necessarily exactly the same.
Oh, interesting. I have not seen that before. Why? Wait, so is it always -1 to 1 no matter what the viewport is? No. That'd be weird.
Yes, the final coordinates of the stuff that you send to your shader is that.
Okay.
So what you actually have to do with all of your coordinates before you get to Fragment Shader land is actually here or someplace earlier than this. You have to compensate for the fact that your aspect ratio might not be 1 to 1.
Interesting.
So it's actually like usually in the Vertex Shader, you're actually like you've baked in the aspect ratio. Yeah, it's a little weird. But I think the reason why they did this is they didn't want to have to deal with aspect ratio at this stage of the rendering.
Regardless of the size and proportion of the canvas. Okay.
Yeah. Another way to think of this, and probably would have been easier if they put 0, 0 in the upper left-hand corner, is that your coordinate system is just like the percentage of the horizontal distance of the screen that the pixel is, right? That's a little bit easier to understand.
Yeah, that's actually, I can see how this could be helpful and clever, so.
Yeah.
Boy.
Yeah, so you can actually see here in their example, they're actually building the vertexes. And this is the vertexes in the JavaScript program. And you notice how they're taking the aspect ratio and they're fudging the values of these coordinates to account for the aspect ratio.
Oh, interesting.
But they want to do a square, and a square is going to have the same values for x and y coordinates, right? You do want 0.5 everywhere, but they're actually fudging it a little bit by the aspect ratio because they know that like the coordinates are going to get emitted in this like weird -1 to 1.
Oh, this is very interesting. So we have we have a flexible viewport, so we need to Well, I guess we just always get the canvas width and height and call it a day. Yeah.
Exactly. We can just call it a day. Probably when the canvas width and height change, we need to like tell it to do something different, right? Basically, that's what this thing does. Like when you, I think what's happening is like you're fudging it here when it goes in to the beginning of the pipeline, and then obviously your renderer knows how to unfudge it, right? Because it's like you can't actually have a window that's not a square, right? So the way it knows how to unfudge something is you call this line 50, right?
Weird.
It knows exactly how to unfudge it because it knows your aspect ratio. So it's kind of funny that like you're kind of like you're fooling around with your geometry before it goes into the graphics pipeline. But then you tell the graphics pipeline exactly how you fooled around with it on line 50, basically. You basically said, okay, look, all the stuff that's going into your pipeline, I've already compensated for the aspect ratio, and by the way, here's my aspect ratio. That's what line 50 is. Now, I think it's just that like it turns out that like probably a lot of math in the Fragment Shader ends up being easier if like you assume that you're using like essentially how far across the horizontal axis you are, or how far the vertical axis you are, versus like actual pixels, right?
Interesting. All right, it's gonna take a second to wrap my mind around all of this. So
yeah,
I look forward to catching up on it. Yeah.
One example is that you know how like video games can like change aspect ratios? Like you can go into the menu and you can change like what resolution you have.
Yeah.
And you can even make it maybe go from like what's 1080p? Is it
1920? 1920 by 1080? Yeah.
Yeah, well what's the ratio on that?
Oh, 16:9.
16:9. You may be able to actually just on the same hardware actually run it at 3:2, right? A 3:2 aspect ratio. But you don't want to have to rewrite your shader for that, right? You don't want to have to rewrite your fragment shader just because the aspect ratio has changed. And I think it shakes out that like that's why they basically do that fudge. They do this advanced fudging in advance kind of thing. Anyways.
No, that makes sense. And if there's a bunch of shaders getting recompiled every time I do that.
Yeah, it's bad.
Right. Well, also it sort of explains why when you change resolution, the whole screen goes black and it has to like pause for a second and be like, hey, did we render the screen for you or not?
That is a fantastic example.
Yeah.
Drivers are stateful. Like the OpenGL driver for your particular graphics card is stateful. There's a lot of state that has to change if you update certain settings, which is probably why you see things blink out and come back in.
Yeah.
Right? That's basically the driver or the game saying like, I don't trust the driver to do this gracefully, so I'm declaring bankruptcy on what's currently being rendered, and I'm going to give myself a little bit of time to rejigger things.
Yep.
Right.
Neat.
Okay. What I would recommend is that we just do this regardless of what is being rendered here. We're just going to draw a freaking thing. How's that sound?
We're going to do it.
We're just going to draw this square.
Cool.
But this website's amazing. It's got a lot of ads. It's great.
So many ads. Does your ad blocker run in incognito, or is there no Chrome ad blocker? Because you're not a Chrome person.
I might not have installed a Chrome ad blocker. Oh, come on, Prettier. I think I might have just broken Prettier in general. It doesn't seem to run automatically for me.
It makes me wonder. I wonder if you can run Prettier from the command palette, or if we have a syntax error that Prettier is actually like still sort of vomiting on in the switch statement.
Yes, this one.
There you go.
That's a really good call. And then this here, I'm still going to comment this stuff out.
Yes. Yeah, let's get rid of it.
There we go. That was very nice. Oh my god, it's horrible.
Is it prettier? Yeah.
Is it pretty? Okay. let's gradually put this together a little bit. I love that it trimmed the semicolons for me. It's fantastic.
Oh, yeah.
This.ctx. I'm starting to see the value of just using this.ctx everywhere. I don't want to have to make a choice, basically. How does it know that item size is 2? Okay, so what are we actually doing here? We know what the aspect ratio is, right? That concept we don't have to go over. But what in God's name is this?
Oh, I've seen this before. This is the item size thing where it's... Oh, it's weird.
Yeah. So this is what's known as a vertex buffer.
Yep.
It is a buffer of vertexes, right? And whether it's triangles or quads or just points on a line, the buffer itself doesn't care. It's how you use the buffer.
Right.
Right. And whether it is if it's vertexes, whether they are 2D vertexes or 3D vertexes or even 4D vertexes, the buffer itself also doesn't care. It's just basically what you tell the driver it is.
Right.
Right. So according to the driver, this is just like raw string data, basically. You can think of it almost like that. And so you have to tell the driver how to interpret this thing. Right.
Right. So we're telling that actually you're rendering points of size 2. So
exactly.
And this is how we're zeroing out the Z and W coordinates. Yeah.
Yeah. So we're creating a buffer. And what this is a piece of memory inside the driver. It's on the GPU basically, but I think it probably also exists inside the driver as well because the driver has to push it over to the GPU. Just imagine this to be like inside graphics land, right? This is this vertex buffer.
Cool.
And this is a little bit confusing. We created this buffer, and you would think we should just manipulate this as an object, but no. We actually have to tell the GPU to put it into this global slot inside the driver called array buffer. Just think of this as there's just like this global hash table at the top of the driver, and there's one slot in it called array buffer, right?
Gosh. Yeah.
And you're going to say the thing that I just created, or you can think of this as a pointer, right? This array buffer thing is a pointer, but what does it point to? It points to this thing that I just created. And then what you can do is you can say, well, now I want to take whatever this is pointing to and fill it with this data that the CPU is going to provide to it, right? And this is how I'm going to use it. Let's worry about that later. So actually, the reason why we have this .ctx array buffer around, we have this like global slot, is because this is not an object-oriented API, right? You'd imagine that like probably the way that you'd want to do this, and I think this might be the way that DirectX works, is like vBuffer dot vert like data, like set data is I don't want autocomplete there. Are these vertices that I've defined?
Right.
But
I mean, this looks like the GeoMatrix API. Like I feel like there's a sort of a common thread running between those two.
That is an interesting comparison. I think I know what you're getting at, but this is a little bit different in that I think basically you can call all of these, like there's like 100 functions that take a buffer name as its first argument. And it's because you want this function and whatever else other functions you're calling to be talking about the same buffer object.
Weird.
But it needs to happen inside the driver, right? You're manipulating driver state. You're not manipulating CPU state.
Oh, that's bizarre. Yeah. Okay.
Does this kind of make sense?
It does, in a very perverse kind of way.
Yeah, so it's almost as if you can think of this as like a global pointer at the top inside the driver somewhere, and you're going to assign that pointer to this memory address.
Yep.
And then now I'm going to do some operations on whatever that pointer is pointing to, which happens to be this buffer at this time. But if I called bind buffer again on something different, then the next call to buffer data with this.ctx and array buffer as the first argument is now going to be manipulating a different buffer. Does that make sense?
Yeah.
Because I basically changed the pointer to point at something else.
Yeah. So why is vbuffer in a variable?
You talking about this one?
Yeah. Versus why isn't it just inlined in line 99?
We could totally do that.
Is there a purpose? Yeah. Okay.
It's not going to matter for us right now, but imagine that we had like buffer 1 and buffer 2.
Mm-hmm.
And then we did some stuff like this. But then maybe we wanted to manipulate buffer 2.
That is also the array buffer.
But then we also wanted to go back to buffer 1 again somehow, right? That's the only reason why you'd want to put buffer 1 into a variable. Does that make sense?
Yeah, totally.
Yeah. Yeah. So your apps, that's actually a super good question. It's like, why do we have to assign to a variable? You don't have to in this case.
Right? Yeah, well, it's just interesting, yeah, given
in fact
the way the rest is structured. Yeah.
Right. Yeah. Static draw.
I wonder.
Oh, you know what? This is a very esoteric. It's starting to come back to me a little bit. It's a super esoteric kind of thing. The contents are intended to be specified once by the application and used many times as the source for WebGL drawing and image specification. You can also set dynamic draw, which means that the contents of the buffer are going to change. This is like a kind of really weird thing that basically says when you actually like fill whatever array buffer is pointing at, this object inside the driver, with this memory, I want you to organize it in a way that optimizes it for this third argument, this use case.
That's so interesting.
Yeah.
Huh.
So we're in a pretty low level world here where the way that like you're taking memory from the CPU, that's just literally this array here, right? And the buffer data function is going to move that into the driver somehow. But it's going to be organized in the driver depending, like you can imagine that like different ways of organizing that data are going to be optimized for different use cases, right? We were recently talking about indexing our component data, right?
That's right,
and you can almost imagine that like this is like how that buffer is being indexed or being structured internally. And OpenGL just happens to have these three use cases. Maybe in the experience of graphics programmers, they realize that like the memory access patterns are different for different use cases, and they realize that you can kind of just like pre-optimize that by preparing it and storing it a certain way.
Boy, it's so bizarre to have to like, yeah, I feel like you're choosing sort of which part of the graphics memory to write into, and that's, no, this whole thing is much lower level than normal, so great.
Yeah, or maybe that like if you do static draw, or if you did dynamic draw, it has to set up a bunch of other internal data structures to help manage that dynamic draw, dynamic nature, right? That could be what's going on here as well, right?
Yep.
Suffice it to say that this is basically a black box to us right now.
Fair.
All right. So what have we actually done so far? We've basically taken this array of numbers, which the driver doesn't really know how to interpret yet. And all we've done is just like carved out some memory inside the driver, and we've copied this memory from the CPU into the driver somehow. Right? Okay. Now, I think as you hinted at before, item size 2, maybe this has to do with the fact that like we need to teach the driver actually how to interpret this data, right?
Yep.
And maybe it means that like every 2 items is a vertex. But we haven't even told the driver that this is actually a list of vertexes yet. It literally just doesn't know. Like right now, this is just a raw string of numbers that we've passed in. Yeah.
Ooh, here we go.
Here we go. Okay. So use program. You know, we had this question before of whether or not we actually like did linking it like make the driver actually use it? And the answer is obviously no, right? So I actually think that this only needs to happen once if we're not going to change it. So I'm going to put this up here.
Gotcha. And if we did link multiple programs, we would be changing them. We would use program like repeatedly and switch back and forth.
Yeah, you know, I bet what happens when you initialize a game. This is what's happening in your load screen. I bet it's like linking a shit ton of shaders, right?
That's probably it.
Yep.
Right, especially if you compile these on the fly for the graphics card. Like, gosh.
Yeah, for a PC game, right?
That's a lot of work. Yeah.
Yep.
So we're it's so interesting. We have a program. I see. We get to set that uniform that the shader wants. Okay.
Yeah. I think you've heard of Metal, right? The new graphics API for for Mac OS, and then there's also Vulkan, which is like the OpenGL version of that. I think all of these. I think all of those things is a recognition that like OpenGL is a little bit sort of long in the tooth, and this API is kind of wonky.
But there's no web metal, is there?
Yeah, and I actually think that Vulkan might even be like you might even be able to like have even like a lower level version of the shader that you ship with your game. Imagine something like
interesting,
like a Java bytecode or LLVM intermediate representation, right? Some lower level, not quite assembly yet, not quite machine code yet, but something that's like maybe looks like a stack machine or it's a register machine. That maybe allows you to not spend as much time interpreting English-looking text when you're running your game. You know what I mean?
Yep.
And maybe it's easier to optimize that way, right? Because that's why compiler toolchains often will like break your source code down into some intermediate representation before it even compiles it down into like, you know, your machine code.
Yeah, that seems reasonable. So interesting. So you would be shipping different sets of shaders to different drivers or to different graphics environments. Yeah. Okay.
Yeah. Or probably. I think the idea. What I'm trying to say is that like you don't need to ship this string. I think with Vulkan and Metal, you don't need to ship this string anymore with your program. You can use something that's like slightly compiled down a little bit. So it'd be like, I think WebAssembly is a good example, right? If you make a program for a browser, but you compile into to WebAssembly, you can send the WebAssembly over the wire rather than sending the JavaScript over the wire.
Gotcha.
Right? Yeah. Okey-doke. So 5 minutes left. Can we get something drawing on the screen in 5 minutes?
Maybe. Set the color.
Yeah.
We're close.
Yes. So program.uColor. This is a very weird thing that they're doing here.
I'm curious if TypeScript's going to allow us to do this one. But let's find out.
I don't.
Well, so is it?
This isn't doing anything. They're just abusing JavaScript here, I think.
Are you sure? Because program has like the fragment shader has the uColor on it. Is this not how the uniform works?
It does, but the program OpenGL is not an object-oriented API.
Okay.
So this property, you're doing this for a temporary variable, right? Like if we crack open our shader program,
I see.
Oh, it's actually up here, right? If we do program dot uColor is literally this arbitrary string that we defined.
Well, that's what I was wondering. Are they relying on the so nothing is actually interpreting this, even in a not TypeScript can't see that for sure, but like JavaScript's not interpreting that either. They just stuck it on the object because you can put properties on strings.
Yes, that's exactly. The important thing about this expression here is that the driver doesn't see this assignment. Well,
sorry, program is the driver does not see the assignment, but program is actually the created program with the attached shaders and the linked. So it's not our string anymore. Yeah.
So the program itself. Think of this as like a file descriptor.
Okay.
In like a C file IO API, right? You know how like for every file, like a read, write, or a seek or a poll, you pass in a file descriptor.
Yep. Well then let's do this without assigning arbitrary values to objects and see what we get. Because yeah,
exactly.
it makes sense to me too. There's no reason that anything would know about this. Yeah.
Yeah. There's no. I think that's just like maybe the author of this blog post taking some similarities. Right?
Especially when you have get uniform location and you have to hand it the program and the value uColor. Like this is yeah.
Yeah.
Mm-hmm.
And this is prettier. Oh, I love the auto fixing.
Mm-hmm.
Greatest thing about this working with this entire code base is the auto fixing.
Oh yeah,
uniform.
It's aggressive.
So look how many friggin' uniforms we have.
Holy
this
shit.
Is just like, again, like
these
are programming the driver. These are all just like a bunch of different formats.
As I say, yeah, this is. I feel like this is because we don't actually have like good overloading in JavaScript.
Well, it's more that we use these primitive types that are overloaded with a bunch of different meanings, right? Mm-hmm. I think it's a little bit similar to this idea where like, okay, we've got a bunch of numbers. Well, what does it actually mean?
Yep.
Are these texture coordinates? Are they world space coordinates? Are they colors?
Mm-hmm.
Like those are all different concepts, but they use the same underlying representation format. And what this like a vast array of uniform functions is telling us is that a lot of these probably have the same input signature, like the same call signature. It's probably just like a floating point value or something like that, but they mean different things.
Yep.
So this is uColor, and the data is a float32 list.
Hey, look at that! It could be you could do colors dot anything from our color table.
Yeah,
we got it.
Nice.
Sweet.
And there's some optional stuff in there that I'm not going to bother with.
Mm-hmm.
So what does uniform FV mean? For FV mean? I think it means uniform for fragment something. Oh, uniform for floating point values vector. It seems like the number and the V is redundant, right? Like if I got rid of this, like you still know what I was talking about, right?
Oh, but the vector is that you're handing it the array. If you took out the V, it wants 5 values. Okay.
Oh, okay. That's dumb.
Or so it claimed.
Yeah. No, I actually agree with you. I totally agree with you. So we could do this.
I don't want to do that. No, I like the vector version. Yeah.
Yeah. I know exactly what you mean. This reminds me of. Sorry, I know we're basically out of time.
That's cool.
I don't know if you've ever like tried to exec something from the C language.
Oh yes.
And they have just like a billion different variants, and it's like, well, maybe you want to like type out every single command line arg separated by commas, or maybe you want it to be an array of strings.
That's so funny.
This is the exact same thing, right? This is the exact same thing.
Yep.
This is great. So we set a color. And this is going to be, I think, exactly the same type of thing that you were observing before. We don't need temporary at all. And now we can actually modify attributes.
Cache relocation, a vertex position. Enable vertex. All right. What? So this is also programmed, but this is from our Vertex Shader.
Yes. So I think what this kind of implies is that the namespace of things you declare at the top of your shaders is common, right? Because it looks like this is just like, I'm going to reach in the bag and I'm going to grab something.
Yep.
Which I guess makes kind of sense because when you link a C program, right, when you link .os together, they share the same symbol namespace, right?
Yeah.
Unless you've declared static, in which case they don't. All right. Enable vertex attribute array. once again.
We're gonna use it twice though.
Oh, we are. Okay. Good eye. Const.
A vertex.
Vertex attrib.
Hmm.
Sure. A vertex position. Let's just keep the convention. I think that's where you're going with, right?
Mm-hmm.
Item size is 2.
Yep. I think it wants us to have defined that outside of the scope of render and init, but whatever.
Okay. So we're passing a bag of parameters in here, but let's talk about a little bit of what we just did here, right?
Mm-hmm.
So what we're saying is that a uniform, you literally just set the value of a uniform straight up in your code, full stop, right? With an attribute array, there is one level of indirection, which is that you basically say, okay, I'm going to grab the position of this variable, a position. I'm gonna basically turn on the attribute array in the driver, and it's going to use this attribute array, right?
Mm-hmm.
I actually don't know why this is necessary.
Yeah, I'm not
100% sure.
That's not clear.
It's basically saying that like we have an attribute. Maybe it's just like it's telling the driver that there's going to be an attribute array for this program. I guess that kind of makes sense because it's not like it knows. It's not like the driver knows. The driver just like sees this program. It's a bunch of bits. It says, okay, I now have this shader program. But the level and direction that I'm talking about is what we're going to do is we're going to take this array that we created down here.
Mm-hmm.
And we're basically saying we're going to actually populate the inputs into our shader using a buffer that we also pass into the driver, right?
Yep.
So it's a little bit like saying, here's my, I guess the web analogy would be like, here's my giant data set. Here's my MapReduce job. And I'm going to send it off to the send both of those things independently off to the MapReduce engine, right? Does that analogy help at all?
Yeah. Yeah. I mean, it's making a rough amount of sense. There is just some wild boilerplate going on.
It's a lot of boilerplate. But I think the reason why we want to do it this way is so we don't have a for loop in our program. Like we had to use uniforms we could use uniforms to actually set the vertex values in the Vertex Shader. But what that would mean is that in our CPU program, so this code that you're looking at right now, we'd literally have a for loop that was going over this in-memory array and setting the uniform every single time.
Exactly.
Yeah. And that means that you can't really parallelize that, right? That means that your GPU is essentially blocked on this single-threaded CPU process, which is like, why are you using a GPU in the first place?
Right.
Whereas if we put everything up front into a buffer and then say like, okay, this is the input into my shader. Now you take your 4,000 cores or however many you have in your GPU and run this shader on that input. Then the GPU and the driver can do lots of cool stuff with it performance-wise, right? So that's what an attribute array is. An attribute array is like, I'm going to send you a bunch of data that the shader will act on in parallel.
Makes sense.
Yeah.
Okay, so we're a little over time, but what is the next step going to be? Draw the triangles? Because I'm curious.
Yeah. So we passed in a bunch of stuff here. We told it how to interpret that array. We said that, okay, this array, this is the name of the array. It's got like, it's a vertex array. Like we said, it's vertex. So actually, that's probably what this enable vertex.
That's what that's doing. Yeah,
basically saying that it's got vertices. And then we say that the vertices have a size of 2 elements. So it's a 2D vertices. They are floating point values. And you have to tell it these things because like when the driver gets it, it's just all bytes.
Yep.
And it doesn't know that it's a float or like a char or whatever, right? So that's why you tell it to float.
That makes sense.
Okay.
Yeah.
And so at this point, you just tell it to draw. So you're right.
Oh, come on. That's fucking hilarious.
Should we just do it?
Yeah, just do it.
All right. I think num items we still need.
Num items we need. Item size could just be 2. Yeah.
Yeah.
And sorry, what the fuck is GL.triangles? Did anything get called GL.triangles?
Well, GL we defined it's. Okay, yeah.
So, sorry, nothing is called triangles though, right?
What's that?
We just didn't call anything triangles yet. Yeah. But like
yeah,
we put this in an array buffer, and now it's just like, all right, at the very end, just use a different variable. It's just very OpenGL of it.
I thought there was quad. Maybe not. Maybe triangles don't exist in GL 2.0. But we could do triangle fan, triangle strip.
What?
Basically, or we can do line. We could just say that what this actually describes is a bunch of 2D vertices that you should connect with one line in between each of them.
Okay.
Does that make sense?
Yeah.
So we haven't actually told it, like there are a couple different primitive modes that you can draw. You can draw triangles, lines, triangle strips, triangle fans. I thought there used to be a quad, but it might not be in this version of OpenGL, right? And what triangles mean is that every 3 items represents a triangle, and I just want you to draw that.
Yep.
Right. Just so you know, a triangle strip means that like these first 3 is a triangle, and this next, and then, sorry, these 3 vertexes is a triangle. Then these 3 are a triangle.
What?
Then these 3 are a triangle.
Huh.
And then these 3 are a triangle. I wish I could draw it for you right now, but
weird.
Imagine like a truss bridge, right? Imagine like the old East Bay span of the Bay Bridge, right? You think of those trusses. That's a triangle span.
Oh, you're
right?
always
basically sharing the previous 2 vertices with the next triangle.
Oh, that's really clever. Okay.
Yeah. And that's all just memory optimization, right? Because you can imagine that you can draw many more triangles with the same data.
Right, exactly. You've saved a significant amount of space.
All right, so did this compile? It's compiled. This is scary. Nothing.
Nothing. You want to look in the console real quick? We might not even know if our shit's not compiling, but...
Yeah. So there's a lot of WebGL errors.
No valid shader program.
Not valid. Okay. Yeah.
Great.
So it's totally possible that like this is just not the version of GLSL that this driver likes. So
honestly, it's great that it threw some very specific WebGL errors for us. That's helpful.
It's really nice, right? Okay, so now we've got some of the concept space down. I think this opens us up for Thursday, actually implementing this.
Yeah, and I can see a really clear path from here to drawing terrain and drawing 3D models and actually, rotating the plane if we want to. So this is really cool.
Yeah, that's exactly right. And what's nice is that I think we're probably, like, our video game actually currently doesn't have any real geometry to speak of.
Yep.
I guess maybe the tank, it has a little triangle, it has a little trapezoidal turret. But there's actually very little geometry to the degree that we could just like hard code the geometry like into this file right here. But
absolutely,
like for terrain, all of those tiles is just going to be squares,
yep.
Right? And what really matters is how we're transforming those squares. And that's basically going to be a different value here. I think maybe it would be another different attribute here, or a different uniform, which is our transform matrix. Right?
Interesting.
It's basically like we'll do a matrix transform against this vertex position because we're moving stuff around. So yeah, that's basically the game plan, the plan of attack.
All right, we bit off another big chunk. This is gonna be cool.
Yeah, it'll be good. I'll put this into branch because I've destroyed a lot of stuff.
Yeah, let's not break the game before Steven gets in here. So maybe this, branch makes sense. Here, put your camera back on for a second. I'll put us back in two heads.
Is this gonna mess up your sorting again?
Not for the we're two heads talking view, which is still correct. So great.
Yeah.
All good. Now it's messed up.
I'll share my screen.
All right. Yeah, you know what? I'm 50-50 on Discord, but it was really good from Windows.
So are you encouraging me to develop from Windows?
I think I might try developing for Windows on Thursday, is what I'm saying.
Oh, that's exciting.
Yeah.
I could do it. I mean, there's some weird things I can't delete. I don't have a delete button. But like...
Oh, sure. I have a delete button. That's gonna help me out.
Yeah, my keyboard's coming in let's say a month. I'm optimistic that it'll come before Christmas.
Nice. I hope so.
Yeah. And then we'll be Windows developers. We'll just go whole hog.
I mean,
just do Windows.
If I wanted to write some Unity, I would sure do it on this Windows PC and not my Mac. So I'm with you.
We are game developers now.
We are
professional, experienced game developers. We are game developers. Windows is the platform for game development.
It sure seems that way, given how the Mac's running all this stuff. So I'm with you.
Yeah. Ugh. Gross.
Yeah, we'll soldier on that one.
Yeah, I hope you don't mind the level of detail that I'm.
This is
talking to the API.
So helpful. No, it's good.
Okay.
No, I am soaking it up because my OpenGL knowledge is about this deep 3 or 4 times. Like, I've gotten to this level. I haven't really gotten much past it, so
yeah,
it's helped me catch up.
Full disclosure. I partly I'm reciting it out loud to remind myself of what all this stuff does because I don't like. I mean, I'm fine using tutorials and I'm like, let's just get it done kind of stuff. But like, I also don't like calling functions when I don't know what they're doing. So,
absolutely, yeah.
Yeah.
No, I'm with you. This is going to be really, really cool though. I feel good about it.
Awesome. All right, man. What's your next game after Hades, or are you going to take a break from games?
That's a great question. Yeah, I don't know. Sometimes you just need a little lull. We'll see.
Yeah.
Or something will grab me. Maybe I'll rejoin you in Ghost of Tsushima.
Assassin's Creed Valhalla.
Maybe, yeah. I'm gonna wait till that's like $10, just like every Assassin's Creed.
Did you play Odyssey?
I'm like 2/3 of the way through it. It's so big. It's too
really
huge.
I feel that way about Ghost of Tsushima a little bit right now. Like I got to the second island. I don't know how far into the game you are.
I'm almost there, yeah.
Okay, yeah. And I was like, oh my god, this island is twice as big as the first one. Which makes sense. I'm 1/3 of the way through the game, and I'm like, God, I already killed a lot of Mongols.
You've murdered a lot of Mongols at this point, yeah. That's so funny.
Yeah.
Yeah, we'll see. But still more Hades until I get that final quest, then I can decide.
Yep.
How about you? Ghosts, or no, you're on a ghost break?
I'm on a ghost break for the next day.
Fair.
I don't know. I think time management wise, I think I'm realizing that like a lot of my video game time and like streaming video time is kind of eating into the other things I would love to be able to do. Like this game, for example. What if I was working on it more consistently outside than just like the 4 hours a week on stream, right? I mean, I do like kind of the bullshit refactoring stuff off stream, but that's like, you can kind of turn off your brain and do that, right? It's not super hard.
I feel like that's meditation for you, yeah. Yeah,
it is.
Which is great.
It's different. It's different than actually having to like make decisions. And what I love about this, the reason why this project is fun is that no hard decision I have to make on my own, right? We're talking about
exactly.
About it. Yes.
Yeah. I think that is the saving grace because oftentimes on my own projects I will get to that and I'll just be like, well, I'm gonna take a walk, and then
I'm gonna go have a sandwich.
Then I forget and then I'm just like, well, it's too much work to come back to this. So
yeah. Well, let me leave you with this quick anecdote, which is that I attended the Handmade Seattle conference virtually over the weekend, which is really cool. And the real kind of money shot demo was like the very last one. I think the coordinator or the person running the conference sort of knew the value of the content that he was presenting.
So of course they saved the best for last, yeah.
Yeah, and it was a couple of like relatively experienced game developer people who really got into tools, and they made this system called Dion, which I think is short for Dionysus. It's Dion. And I'll upload the video for you to watch.
Please.
It's already online, but I kind of actually cut it down so I could share it because that was how excited I was. It's like I want people to be able to see this. But basically, Dion is a programming language, but it's really more of like a programming environment. The way that like Smalltalk was actually like really more about a programming environment, right?
Interesting.
I guess you could almost make the same case for Objective-C, right? Like, I felt like Next in that whole world of programming was really all about like interface builder and like how everything kind of was like super tightly integrated. But their innovation is that the language-based representation is not text. It's not like a text file that your code is in. It's the actual AST of the program.
Whoa.
So like basically you're in your editor, and as you're typing names of things, you immediately get like an autocomplete dropdown that says, okay, what you're actually talking about is this syntax object or parser object. So that means you can have things like spaces in your variable names, right? Because it knows dynamically that like you're actually referring to this particular variable. And then also when you reference that variable inside your function body, for example, those are all just like pointers to the same thing. So you can like, as soon as you rename the declaration, it'll like automatically do the rename symbol thing for you.
Oh.
What? And then also, things like the way that the source code is rendered is just pure visual representation. So like what your bracing style is, you can just like set it as a editor option, or what your if you're doing tabs versus spaces, or how big your indent is. You like all of these things are just, it's an AST at the baseline representation. So it doesn't actually care about white space at all, right? Like it's in it, and like it knows indentation because like all the things that should be indented are children of another object. It's actually the actual like tree of programming objects.
Dude,
so
this is weird.
Yeah, but it's super rad and powerful because what the really exciting thing about it, like everything I talked about so far is kind of superficial, like spaces and variable names and that kind of thing. But the really exciting thing about it is that it actually doesn't have a notion of like where a function lives. So you can say like, well, maybe what I really care about is all of the functions that take this type of thing as the first parameter.
Whoa.
And I want to show all of those things side by side. Right? Because it's just like it's just an AST. It doesn't really care about like like the idea of like a piece of code living in a file doesn't matter. It just knows the whole program, you know.
You're gonna have to send me this video. This is bizarre.
It's super rad. Yeah.
That does remind me of Smalltalk though, because I've seen how people use that pre-Objective-C and how utterly thrilling it was to like. Yeah, I don't know, the way message passing seemed to work in such a fluent way. The sound, I can see why you're describing this as that. Damn.
So the reason why I gave you this anecdote is that the people that are working on that are probably not spending 20 hours of the weekend playing Ghost of Tsushima. That's basically.
It's true. Do they have day jobs though? Because I feel like that's where a lot of my good energy goes too.
That's a really good question. Yeah, like can you successfully do the day job thing and code in the evening?
That's what I always wonder. But we successfully do it. I'm happy with the 4 hours because it's 4 hours more than I was doing before. But
yeah, baby steps.
Baby steps. Yeah, but also I do want to work on this thing a lot.
Yeah. All right. Well, we'll get there, Dom.
Oh yeah.
I believe in you.
I believe in you. We're doing it. And it's gonna be 3D soon, which I thought multiplayer was a big lift.
Yeah, and then 4D in 2021.
Absolutely. I can't wait to find out what the W coordinate is for.
Yeah. I don't even really know, but I have a very vague understanding of that. So we'll find out together.
Sweet. All right, cool. See you, Twitch. Signing off.